Alright, so welcome to another Autodesk Inventor video. Today what we're going to do is we're going to create a square to round transformer. Okay, so that's a mechanical component that's commonly used in things like heat and ventilation systems. I'm going to run through this with you and then hopefully you'll be able to have a go yourself. So to access the file that we need, we're going to come up to this new tab and we're going to click on new. And what that'll do is it'll open up this box. Now hopefully your metric command box will already be open, but if it isn't, if you drop your ENUS done, you'll see a metric box there. Now the file type that we're going to be looking for is the sheet metal MMIPT, so we'll select create. Alright, now what we've got along the top ribbon bar here, we can see the sheet metal commands. Now we're going to use some of these, so it might be new to you, however we did use these when we were creating the cone in a previous video. But for this one, what we're going to do is we're going to start creating a sketch and then we'll work our way through this together. So I'm going to select a 2D sketch. So I've got a square to round transformer, so it's going to be square on the bottom, round on the top. And I'm going to make sure I'm going to use this 2-point center rectangle command to create that square. Now I've got some dimensions written down on a bit of paper in front of me. So the square that we're going to do is going to be 250. We'll hit tab and it will take us into the other dialog box and we'll hit enter. And obviously our square hasn't appeared on the screen because we need to zoom out using the wheel on our mouse. Okay, so next thing we're going to do, we're going to select finish sketch and we'll zoom out again so we can see what's happening here. Alright, now we need a work plane up here somewhere so we can put another sketch onto. And to do that, there's a couple of different techniques. I'll show you my preferred method and then you can obviously work out any others yourself. So what I'm going to do is I'm going to drop this origin tab down and I'm going to switch on the work plane that I drew on earlier, that XZ plane. Okay, now I can bring that back into the middle of the screen if I want. I'm going to select this command, which is work plane, which is a very handy tool to get your head around. Now if I just hover over the initial work plane that I drew on, and if I left click on that, what I can do is drag that away from there. So to offset it. Now if I want to offset it a specific distance, I'll type that distance in. I'm going to make this one 200 millimeters. Okay, and I'll realign this so I can see this work plane. Now I'm going to put another sketch on top of that. And this time, the sketch that I'm going to use is going to be round. And I can offset this, so I could bring this over here if I wanted and put on. But I'm going to put mine nice and symmetrical in the middle, just so that we're starting off on the right foot. So if I type 150 in there, what that's going to do is it's going to allow us to create a round object at the top. So it's square on the bottom, round on the top, and I'll swing that around so we can see what's actually going on. Alright, now if I hit finish sketch, what that'll do is it closes down any commands you've got open. And then the next command that we're going to use is one that we used on the cone, which is this lofted flange command. Okay, so the profile I'm going to select is the bottom one, and the next profile, which has already jumped onto that for me, is this one. Now when I select this, what we'll see is I've got an object, a square to round transformer on the screen. I'm going to OK that. Now it's important at this point that you remember that these sizes that we've put in this can be changed to anything you want really. You have to be a little bit careful so that you don't make it too small, because otherwise your flange won't work. But we can make the bottom 400 millimeters, the top 200 millimeters, the bottom a meter wide, the top whatever we want. Right? So we can adjust these sizes to whatever system we're working on. Now the next thing that we're going to do is I'm going to run through how to create a flat pattern of this. Alright, and that flat pattern can be used to be sent to a thing like something like a CNC laser cut machine, which will allow you to actually create that component, cut it flat and then send it to the fabricator who would fold it up for us. So the command that we're going to use here is going to be this rip. So I'm going to select what face I want to rip. In this case I'm going to choose that one for no other reason than it's in the center. The rip point is going to be here, and what that does is it puts a little gap in between there, so it basically cuts that object down that line. You can change that gap to whatever you want, so it's already set to 0.5, which is fine for me. I'm going to OK that. If I wanted to rip it in different places, then I can just apply it and then go from there. The next one I'm going to do is I'm going to select create flat pattern, and what that's going to do is it's going to unfold this object for me. Alright, so what I've got is I've got that object has been unfolded. Now, as I mentioned earlier, that could be then sent to a CNC laser cut machine, which will cut that out for us, or we could actually print a template of that and then we could draw around it and then cut it by hand. We can even put our bend order annotation on there. So let's see what happens there. So what that does is it will put a little annotation on the printout of the actual model, which tells you what order they need to be bent in, so you can see it puts that on. So it's a really handy feature. We'll go back up to folded part and it just rounds that off for us. So make sure you save that, and then obviously if you need to address any sizes, changes, etc., you can do them in your browser bar. But you can worry about that at a later date. So thanks for listening, and good luck with doing your run.